I realize that my chicken scratch is going to be difficult to see, but this information is available in your machinery's handbook, and it's also available all over the internet. So I'm going to do an FEA analysis on a cantilever beam. And for this particular problem, I'm going to use inch-pound-second units. For later problems, I'll also use metric units. I have a beam that is a square 1 inch by 1 inch square and 24 inches long. My material is mild steel with these properties of elasticity, yield strength. Load will be a 150-pound load on the right side end, with a fixed constraint on the left side end. If you do the hand calculations, and again these are in the machinery's handbook, I come out with a hand calculation with a displacement of 0.272 inches. I get a calculation of the stress, 21,600 psi, and a calculation of the safety factor of 1.4. Let's set this up in Inventor and see if we get the same numbers in Inventor that we get with our hand calculations. I'm going to start by creating a new part file, and I'll go ahead and save this as lab number 1. I'm then going to start a new sketch on the XY plane, and I will draw a rectangle in space to the right of the origin, and I'll put a coincident constraint from the midpoint of this vertical line to the origin. Now it doesn't really matter where we locate that constraint, and I will dimension the height of this rectangle as 1 inch, and I'll dimension the width of it as 24 inches. Alright, then I'm going to extrude this, and I will select the distance for the extrusion using this variable. So I'm going to go mid-plane 1 inch for the extrusion. Save it. Alright, now I'm going to assign the material, and so I'm going to assign steel, and I haven't decided whether I want to do steel or steel mild. Let's look at the properties of steel, and so I'm going to click here, and I'm going to click the edit pencil, and I will go to the physical tab, and I'll go to the mechanical and the strength, and I see that these units are in metric units, so I want to look at this in inch units since my problem was given in inch units. So I'll cancel out of that, and I'll come down here and I'll say set display units, and instead of meters, kilograms, pascals, I'll set inch, pound, second. Alright, now I'll click on this edit pencil, and I'll go to the physical tab, and I see that Young's modulus 3.046 and the yield strength 3.002 times e to the 4 psi. Now if you're not familiar with scientific notation, you're probably not quite ready for doing FEA analysis yet, so go back and review scientific notation if you have forgotten what that means. I'm okay with the properties of this that match our problem description, but I'd like to change the color of this part just to make it easier to see as we continue on, and so I'm going to set this to a light gray, and I'll save this setting, and then I'm going to go into the FEA analysis. So I'll go to Environment, Stress Analysis, and I'm going to create a new study. This will be a static analysis, single point analysis, so we don't need to make any changes here. We'll say OK to that. I've already assigned my material, so I don't need to go in and make any changes there, but if I wanted to do an analysis, say with steel, with aluminum, with different materials, I could just copy this study and then just check with each individual material. So I'm going to then do a fixed constraint on the left end of my part, and we're going to do this analysis without consideration of gravity. The part's only 24 inches long. Gravity would have a minimal effect on this part. Then I'm going to do a force on this end, and I want that force to be pointing down, so I'll get the selection tool, and I could either pick this edge so it follows that edge, or I could select this face. It will then be perpendicular to that face, and I'm going to do 150 pounds force. I'm then going to come over here, and I want to select mesh view, and we see that it meshes our part. Now we may want to increase that mesh density, but for now I'm just going to leave it on the default setting for that mesh density. In future problems we may run a convergence analysis where we increase that mesh density, but I'm going to leave it on the defaults, and I'll go ahead and run the simulation. When I run the simulation, I get a stress value of 21.77. If you recall my, and remember, this is KSI units, thousands of pounds per square inch, And if you remember in my hand calculations, I had 21,600. Here I have 21,007. So essentially it is the same number. If we calculated the percentage difference, you know, it's less than 5% difference from our hand calculation. And if we had, say, 20 of these beams and we did a physical experiment where we put 150 pounds on the end of it, we're going to get a slight variation from one beam to the next anyway, but it should be within a ballpark range. And we're doing finite element analysis, not infinite number of elements, finite element analysis, and we haven't refined these elements. We're really close to our hand calculations. And let's go to the displacement. For the displacement, I have a value of 0.272 inches. That's identical to my hand calculations. And if I do then the safety factor calculation from the hand calculation, I had 1.4. If I round this off, 1.38 is 1.4. So we get identical numbers, essentially identical numbers to our hand calculations. I'll go back to this displacement for a moment. So I have a displacement of 2.72, or about 1/4 of an inch. And remember, this thing was 1 inch. It looks like it has displaced 1 inch, more than 2 inches. It's one of the most common issues that comes up, or questions that comes up on the internet, is I know that the displacement, it isn't this amount, but they've ignored, here's the amount over here. This is just a pretty picture. And in fact, this has been adjusted so that we can easily see it. If I put it on actual, in this case we can see about 1/4 inch displacement, but a lot of times we have so little displacement we can't really see it, and so we exaggerate this. We use this adjusted exaggeration to make it more obvious what we are looking at, or where the displacement is occurring. Okay, so that was a first test. We compared the analysis in Autodesk Inventor against our hand calculations, and we got essentially the same value.